nucleophilic substitution reactions of haloarenes. Haloarenes are less reactive towards nucleophilic substitution reactions. Okay, but under drastic condition, the reaction takes place. That is, at a very high temperature or high pressure, the reaction takes place easier. First one, reaction with sodium hydroxide. NaOH. Okay, reaction with NaOH. First, chlorobenzene or haloarene on reaction with or heating with aqueous NaOH at about 623 Kelvin and 300 atmospheric pressure gets converted into phenol. Okay, chlorobenzene heating with aqueous NaOH. Okay, NaOH at a temperature of 623 Kelvin and 300 atmospheric pressure. First, it gets converted into sodium phenoxide, ON. Okay. Then, next acidification takes place. It gets converted into phenol. Okay. This is the first reaction with NaOH. Okay. But this reaction can be made fast, or the reactivity of the chlorobenzene or haloarenes can be increased by the presence of certain electron withdrawing groups at the para and ortho position. Okay, electron withdrawing groups like NO2 groups. Okay, let us take some examples. Okay, if NO2 group is present at the ortho and para positions, the reactivity of the chlorobenzene or haloarenes will increased. Okay, first let us take one example. If NO2 group is present at the para position, okay, the reaction takes place on heating with NaOH at a temperature of 443 Kelvin. The reaction takes place. So the temperature is reduced. Okay, and next on acidification gets converted into phenol. Okay. Next, if NO2 is present at ortho and para positions, again the temperature is decreased. Okay. Next, chlorobenzene. If NO2 is present at ortho and para positions, okay, on reaction with NaOH, the reaction takes place at a temperature of about 368 Kelvin. So temperature is again reduced, and acidification gets converted into phenol. Okay. 2,4-dinitrophenol will be obtained. Okay. Next, if 3 NO2 groups are present, at ortho and para positions, okay, the reactivity again increased. The reaction takes place at warm hydrolysis takes place. Okay, the product obtained will be trinitrophenol. Okay, these are the different reactions. So by the presence of electron withdrawing groups, the reactivity of the haloarenes can be increased. Okay. Now, if NO2 group is present in the meta position, there will not be any influence on the reactivity. Now, let us discuss the mechanism, how this happens at as the NO2 group present at ortho and para positions, how this reactivity increases. We can explain the mechanism one by one. Ortho substituted, para substituted and meta substituted. Meta substituted will not influence if NO2 is present. Let us explain that. First one, if NO2 is present at the here, if NO2 is present in the para position, okay, This one. The different resonating structures of this compound are okay. So what will happen? The OH minus will come and attack here. Okay. So this bond will shift towards here. So OH, Cl, okay, minus charge here, N double bond O minus. Next. So this bond will shift and a negative charge will come here. Okay. So this is an electron withdrawing group. This electron withdrawing groups can withdraw electrons. Okay. So the total electronegativity of this aromatic ring decreases. Okay. Negative charge here, N double bond O minus. OH, Cl. Next structure. This minus charge moves here. Like this. Minus charge will be here. OH, Cl. These are the slowest steps. Okay. Slow step. Slow. Okay. Next step is the fast step. Okay. So what will happen? Smooth here and chlorine will move away from the group. So the product obtained will be like this. Okay. N double bond O minus. So this will be the mechanism of para-nitro if NO2 is present in the para position. Okay, para position of the haloarenes. Okay, this is the first mechanism. Now let us discuss the second mechanism if NO2 is present in the para position. Okay, we know at the para position also there will be a negative charge in the resonating structure. Okay, let us see that. Cl. Okay. Sorry, here. N double bond O minus. So OH minus will come and attack here, shifts here. Okay. So different structures, resonating structures will be like this. Minus charge. Okay. NO2 here. OH, Cl. Okay. It moves here. Then next structure. Next. So here also there will be a negative charge in the ortho position. So this NO2 withdraws electrons. Okay. Minus charge here. N double bond O minus. Okay. So in the next, these are the slowest step. Next is the fast step. Okay. So next step, shifts here and chlorine will move away from here. This is the fastest step. So OH double bond O minus. Okay. So these are the different resonating structures of if NO2 comes in the ortho position of a chlorobenzene. Okay. Now let us discuss what will happen in the case of meta position. If NO2 comes in the meta position. Okay. Cl. Okay. Here NO2 comes. OH minus. Okay, it moves here. So, slower steps. First resonating structure, minus charge, OH, Cl. Okay. Next. N double bond O minus, OH, Cl. These are the slower steps. Okay. Now shifts here, okay. So we can see that here there is no negative charge in the meta position. So NO2 will not withdraw the electrons from the ring. Okay. So there will be no effect or the reactivity, there will be no change in the reactivity if NO2 comes in the meta position. Okay. Next, first step. OH. Okay. Double bond of O minus. So these are the different resonating structures or the different mechanisms. If NO2 comes in the meta position, that will not make any change in the reactivity of the haloarenes. Okay. These are the different reactions takes place in the presence of NaOH. Okay. Reaction with NaOH. Okay. Next, one more nucleophilic substitution reaction, that is reaction with ammonia. Reaction with ammonia. So chlorobenzene on reaction with ammonia in the presence of a catalyst Cu2O, cuprous oxide. Okay, in the presence of the catalyst and the temperature of about 475 Kelvin, the reaction takes place and chlorobenzene will converted into amines. Okay, aniline will be obtained like this. Cl. Okay, on reaction with ammonia. In presence of Cu2O, the reaction takes place and chlorobenzene gets converted into an amine. Aniline will be obtained. NH2. Okay. Plus Cu2Cl2 plus H2. Okay. These are the different nucleophilic substitution reactions of haloarenes. Okay.